Hello everyone, this is our session 4 on pairs of straight lines. We're moving on to the next topic. It's called as angles between the lines represented by ax square plus 2hxy plus by square equal to 0. Okay, so now if we have a combined equation of two lines, then we should know the angle between those two lines. So there's a theorem on that. Let me just write the theorem for you first. So it says that if theta is the angle between acute angle between the lines given by, let's write that down. So if theta is the acute angle okay, so the theorem says that if theta is the acute angle between the lines given by ax square plus 2hxy plus by square equal to 0, then prove that tan theta is equal to 2 root of h square minus ab upon a plus b if a plus b is not equal to 0. So first of all, we'll try and find out the acute angle between the two lines. Then we'll try and understand this condition a plus b not equal to 0. So we'll say that let m1 and m2 be slopes of the two lines represented by ax square plus 2hxy plus by square equal to 0. Okay, so if m1 and m2 are their slopes, then what are the two equations of the lines? We can write separate equations. Now we can write the equations as y is equal to m1x, okay, and y is equal to m2x, okay. Then we'll find out the combined equation based on m1 and m2, okay. So we can write that as y minus m1x, or rather, let's put it as m1x minus y, okay, m1x minus y and m2x minus y equal to 0. Let's find the combined equation. So we'll have m1 m2 x square minus m1xy minus m2xy plus y square equal to 0. Okay, can be written as m1 m2 x square minus common m1 plus m2 xy plus y square equal to 0. Now let us compare this with our equation ax square plus 2hxy plus by square equal to 0. So we can write the ratio of the coefficients because they both are the same two equations. This is also combined equation of the same two lines, and that is also combined equation of the same two lines. Okay, so we'll call this as, the first one is equation 1, and this that we found out now is the equation 2. So we can write the ratio of the coefficients as m1 m2 upon a, okay, is equal to minus m1 plus m2 upon 2h is equal to, last coefficient we have 1 upon b. Okay, therefore we can say that m1 m2 is equal to a upon b, and m1 plus m2 is equal to minus 2h upon b. Now see, we knew these equations already, but since we're doing a proof, so we need to write down how we get these values. Okay, so that's why we have written this as m1 plus m2 and m1 m2. Now using the identity m1 minus m2 the whole square is equal to m1 plus m2 the whole square minus 4m1 m2. Okay, so we don't know m1 minus m2, we leave it as it is. M1 plus m2 we know, that is minus 2h upon b the whole square minus 4 into a upon b. Okay, so m1 minus m2 the whole square is equal to 4h square upon b square okay minus 4a upon b. Let's take the LCM. So we'll have b square down and 4h square minus 4ab. Okay, so which will be 4 common, h square minus ab upon b square, b not equal to 0. This has to be mentioned whenever you have the denominator. Okay, now m1 minus m2, that is taking square roots. m1 minus m2 modulus sign, because we're taking only the positive square root now. So we'll have 2 upon root of h square minus ab upon b. Okay, and the positive value. Yes. So m1 minus m2 is this. Now, why did we find out m1 minus m2? So because the question says to find the angle between the two lines, tan theta. So we know the formula for tan theta as m1 minus m2 upon 1 plus m1 m2. Okay, if m1 m2 is not equal to minus 1, m1 into m2 is not equal to minus 1, that is denominator should not be equal to 0, then we can write this as m1 minus m2 value is 2 root of h square minus ab upon b divided by 1 plus m1 m2 value is a upon b. So let us put the value a upon b over here. A upon b. Okay, so taking the LCMs, we'll have 2 root of h square minus ab divided by a plus b under the mod sign tan theta value. Now, tan theta is the angle between the two lines, and here we write if a plus b is not equal to 0. Okay. Now this is the basic theorem where angle between the two lines, let's go back to the theorem. If theta is the acute angle between the lines given by x square plus 2hxy plus by square equal to 0, then prove that tan theta is equal to 2 root of h square minus ab upon a plus b if a plus b is not equal to 0. So we have proved this over here. That is the value of tan theta. Now let us move to the conditions. Okay, so there are some conditions that we should know after knowing the angle between the two lines. The first one, if b is equal to 0, okay, if b is equal to 0, what happens is the combined equation changes to ax square plus 2hxy equal to 0. Okay, therefore we'll have x common and a plus 2hy equal to 0. Okay, therefore we have two lines x equal to 0 and a plus 2hy equal to 0. So that in diagrammatic form can be said that x equal to 0 is basically the y-axis. So one equation is the y-axis, and the second equation a plus 2hy is passing through the origin. Okay, so that's passing through the origin, a plus 2hy. Okay, this will make an angle, let's say theta 1, and let's say theta is the angle between the two lines now. Okay, y-axis and a plus 2hy. So how will we find out this theta angle now, when one of the lines is the axis and the other one is passing through the origin? So how would we find this? So we'll say that let theta 1 be the slope or inclination of a plus 2hy with the x-axis. Okay, and theta be the angle between y-axis and a plus 2hy. Slope of a plus 2hy is equal to m1 is equal to, what it will be equal to now, minus, or you can say, let's say it is tan theta 1. Okay, m1 is tan theta 1. Therefore, theta 1 is equal to tan inverse of m1. Okay, so this is how you'll find slope of the first line. Now, how do we find theta? So we'll say let theta be angle between a plus 2hy and x equal to 0. Therefore, from the figure, theta is equal to, now from the figure, how can you write down theta? Can it be written as 90 minus theta 1? Yes, so pi by 2 minus theta 1. Okay, therefore, theta is equal to pi by 2 minus, what is theta 1 value? Tan inverse of m1. Okay, so this is what we will use if we have b equal to 0 to find the line angle between the two lines, that is the y-axis and the other line that is passing through the origin. This is the first case. The second case will be conditions for perpendicular and coincident lines. So conditions for perpendicular and coincident lines. Let's do the perpendicular lines first. Okay, so if we have two lines OA and OB represented by ax square plus 2hxy plus by square equal to 0, and OA and OB are perpendicular to each other. If they are perpendicular to each other, what will happen? What will be the angle between them? 90 degrees, right? So if the angle is 90 degrees, we can say that the product of their slopes will be -1. Okay, therefore m1 m2 is equal to -1. Okay, therefore what is m1 m2? It is a upon b from the auxiliary, from the main equation, right? So a upon b is -1. So we have a is equal to minus b, and therefore a plus b is equal to 0. Here we come to that condition where a plus b should not be equal to 0 if it's an acute angle. Okay, so if a plus b is 0, that means theta value is 90 degrees. That is, angle between the two lines is 90 degrees. Okay, so the condition for the lines to be perpendicular is a plus b should be equal to 0. Now what is this a and b? This is the coefficient of x square and coefficient of y square. Addition should be equal to 0. The second condition, OA and OB coincide. Okay, now when they coincide, we say that therefore m1 is equal to m2. Now if m1 is equal to m2, then in the auxiliary equation, bm square plus 2hm plus a equal to 0. Okay, the auxiliary equation has equal roots. Now when does an equation have equal roots? When the discriminant, that is 4h square minus ab, is equal to 0, that is h square is equal to ab, h is equal to, or h square equal to ab is fine, so we leave it at h square equal to ab. Okay, now in this case the quadratic expression is a perfect square. Okay, when the slopes are equal, we say that the discriminant, if you know of the discriminant, 4h square minus ab is equal to 0, h square is equal to ab. Okay, so we have to remember when are the lines coincident, when h square is equal to ab. When are the lines perpendicular? When a plus b is 0. Okay, So these two conditions are required before we begin with the next exercise. Let's go on to exercise 4.2 now. Okay. So exercise 4.2 says that show that the lines represented by 3x square minus 4xy minus 3y square perpendicular to each other. So the first question itself very simple. We'll simplify the theory that we just studied. 3x square minus 4xy minus 3y square, okay, is equal to 0, are perpendicular to each other. So when we have, let us first write the comparison values, that is comparing with ax square plus 2hxy plus by square equal to 0. So a is equal to 3, 2h is equal to minus 4, and b is equal to minus 3. Okay, when the lines are perpendicular, we know that what have they asked us to show that the lines represented are perpendicular. Okay, for the lines to be perpendicular, what should we know? A plus b is equal to 0. Let us find out a plus b. Okay, so for the above lines, to be perpendicular, a plus b should be equal to 0. Okay, therefore 3 minus 3 equal to 0. Therefore lines are perpendicular. So mention the condition, check whether it's true, and therefore we can say that it's true. Okay, question 2 says show that the lines are coincident. For them to be coincident, h square should be equal to ab. Easier to understand. Okay, then find the value of k if lines represented by kx square plus 4xy minus 4y square are perpendicular. Simple. Use the a plus b equal to 0 condition and solve. Okay, find the measure of the acute angle between the lines given by. Now they have given us four set of lines, and you have to find the acute angle between them. So I'll just do one of them for you. Question 4, first one now. Okay, so question 4, first one. What is the equation given by 3x square minus root 4 root 3xy, okay, plus 3y square equal to 0. Now what is tan theta given by? So we'll say angle between the lines is given by, let us write the value of tan theta first. So tan theta is equal to 2 root of h square minus ab upon a plus b. Okay, so comparing the above equation with ax square plus 2hxy, a is equal to 3, 2h is equal to minus 4 root 3, and b is equal to 3. Therefore, h will be equal to minus 2 root 3 over here. Okay, let us find the value of tan theta now. So tan theta is equal to 2 root of h square minus ab, 2 root of, what is h square? It is minus 2 root 3 square. Okay, minus ab, so minus 3 into 3, 9, divide by a plus b, that is 6. Okay, so we have 3 here. This will be under root of 4 into 3, 12 minus 9 upon 3. Okay, which is 12 minus 9, sorry. 12 minus 9 is root of 3 upon 3. Okay, rationalize this, so we'll get this will cancel out and we'll get 1 upon root 3. Okay, therefore theta is equal to tan inverse of 1 upon root 3. What is tan inverse of 1 upon root 3? It is tan of 30. So theta is 30 degrees, the angle between the lines. Simple. Compare it with the standard equation. Okay, then write the formula for tan theta, that is 2 root of h square minus ab upon a plus b, and substitute the values, get the value for theta. All the four sums are of the similar manner. Okay, let's move to question 5 now. Find the combined equation of the lines passing through the origin, each of which making an angle of 30 degrees with the line 3x plus 2y minus 11 equal to 0. So they say that you have to find the combined equation of the lines passing through the origin. Okay, of which making each of which making an angle of 30 degrees with the line. So given line we have is 3x plus 2y minus 11 equal to 0. Okay, so this is the equation of line we have. Now each of the lines that are passing through the region are making an angle, same angle, 30 degrees. So we'll say let m be the slope, or rather we can say slope of the line, one of the lines passing through origin. Okay, and making an angle of 30 degrees with given line. Okay, so we have taken another line which is slope is m passing through the origin, making an angle of 30 degrees with the given line. Okay, so how will this help us? Now first we'll find out the slope of the given line. How can we do that? We already have the equation of the line, so let's use the equation. 3x plus 2y minus 11 equal to 0. So we have 2y is equal to minus 3x plus 11. Y is equal to minus 3 upon 2 x plus 11 upon 2. So minus 3 upon 2 is the slope of this line. Okay, so let m1 equal to minus 3 upon 2. Okay, slope of the given line. Now theta between the two lines, that is, let's write this here as let theta be angle between m, slope with line, slope of the line that we need, okay, and m1 that is given. So we can write this as tan theta is equal to m minus m1 upon 1 plus m1 m1. Now m1 normally we write as m1 minus m2 upon 1 plus m1 m2, right? So here m1 minus m2 has become m minus m1. Okay, now theta is already given, angle between them is 30 degrees. Tan 30 is equal to m minus, what is m1 is minus 3 upon 2, okay, upon 1 plus minus 3 upon 2 into m. Now what is tan 30? It is 1 by root 3. So 1 by root 3 is equal to m plus 3 upon 2, or 2m plus 3 upon 2, and we have 2 minus 3m upon 2. This cancels out. We have 1 upon root 3 is equal to 2m plus 3 upon 2 minus 3m. So we'll square on both sides. We'll get 1 upon root 3 become 1 upon 3 2m plus 3 the whole square upon 2 minus 3m the whole square. Okay, let's cross multiply. So we have 2 minus 3m the whole square is equal to 3 into 2m plus 3 the whole square. Okay, let us solve this equation. Now when you expand it on both sides, what will you get? 4 minus 12m plus 9m square is equal to 3 multiplied by 4m square plus 2 3s are 6 2s are 12m plus 9, okay, which is 4 minus 12m plus 9m square equal to 12m square, 36m, so 27. Okay, so our final equation will be, let's send 9m square on that side. So 12m square minus 9m square is 3m square. Okay, plus 36m plus 12m will be 46, 47, 48. So plus 48m plus 27 and minus 4 is plus 23 equal to 0. Okay, now if you can observe this equation, this is of the type pm square plus 2hm plus a equal to 0, like the auxiliary equation. Okay, so we can say that this is the auxiliary equation okay of the two lines which are making an angle 30 degrees with the given line. Okay, simple. So I'm writing this only because whenever you refer to this, you know that what auxiliary equation, why has this come? So this has come from one of the lines angle, okay, and one of the given lines m1. Now the given line has no relation to the combined equation that we are finding, okay. That's why we have only used the angle that it is making with the combined equation. Let's find the combined equation now. So 3m square plus 48m. Now here we'll say that m is equal to y by x. Okay, so normally slope is given by y by x. This is the auxiliary equation whose joint equation is given by a and b m square plus 2hm plus a equal to 0. So here we'll put m as y by x, and therefore our equation will become 3m square 3 into y by x the whole square, okay, plus 48m, so 48 into y by x plus 23 equal to 0. Taking LCM, we get 3y square plus 48xy plus 23x square equal to 0. This is of the type ax square plus 2hxy plus by square equal to 0. Hence, it has given us the combined equation. We did not have to find two separate equations to get the combined equation. Okay, here we are done with exercise 4.2. There are just two more sums which you can try on your own. They're very easy. Okay, try solving them. If you have any doubts regarding the same, I'm here to help you out. If you need any assistance other than these sums, do let me know. Thank you so much.